So our today's video is in the continuation of the previous video. It is a part 2 of the Fourier transform and Laplace transform. Last time we did 7 questions. Now we have to do the 4 more questions. So our another question is from 2016 June. It reads as, what is the Fourier transform integral of dx e to the power I kx fx of fx equals to delta x plus summation n equals to 1 to infinity dn by dxn delta x, where delta x is the Dirac delta function. Now what is fx is given like this. Now if we have to take the Fourier transform of fx, we write it as minus infinity to infinity e to the power I kx dx fx. This comes out to be f of d. Since we know that the Fourier transform of a derivative function is given as dxn, that is dn fn equals to I minus I k to the power n f of fx, that is Fourier transform of fx. Now fx is given to be delta x plus summation n equals to 1 to infinity dn by dxn delta x. Now when we write this this particular part, what we get is del prime x, that is the first derivative with respect to x, del double prime x, that is double derivative of with respect to x, delta triple prime x, plus so on. It goes till n times. Okay. Now Fourier transform of fx is, fx will be, we take the Fourier transform of the above, that is this one. Okay. So this becomes f of delta x plus f of delta prime x plus f delta double prime x plus f delta triple prime x, plus so on. Now f of fx equals to f of delta x. Now the first thing is that is the first derivative of delta x is will be from this equation. Now we will apply this formula. Now by using this formula, what we can get is, here for the first term, this term we get is minus ik f of delta x plus minus ik square f delta x plus minus ik cube f of delta x, plus so on. This becomes 1 plus minus ik plus minus ik square plus minus ik cube, plus so on. Now you can see that it is the expansion of 1 over 1 minus x, sort of 1 over 1 minus x expansion. When we take this 1 minus x to the power minus 1, this becomes 1 plus x square plus x cube. By using this expansion, we get is 1 of 1 minus minus ik. This becomes 1 over 1 plus ik. So this is the correct option, 1 over 1 plus ik, that is option 2 is the correct answer, option B. Now another question is from 2015 December, that is the Fourier transform of fx is f tilde k equals to minus infinity to infinity dx e to the power I kx fx if fx equals to alpha delta x plus b delta prime x plus gamma delta double prime x, where delta x is the Dirac delta function and prime denotes the derivative. What is f tilde k? Now in order to do this question, what we have to do is, first I will write the fx repeatedly, that is alpha delta x plus beta delta prime x gamma delta double prime x. Okay, now Fourier transform, as we already know from the previous question, that Fourier transform of a derivative is given like this. This is important, please remember that. Then Fourier transform of f prime x is minus ik f tilde k. Okay, Fourier transform of f double prime x minus ik square f tilde k equals to minus k square f of k. Therefore, so f of delta x equals to minus infinity to infinity e to the power I kx dx. Fx is 1. This is given to be 1. Now f of del prime x will be minus ik and multiplied by 1 will be minus ik. Okay, now f of delta double prime x will be minus ik square, and the Fourier transform of delta x is 1 as done in the previous step also. This is equals to minus k square. Okay, now we substitute all these transformations in the given transformation which have to solve. Beta delta prime x plus gamma delta double prime x equals to alpha minus I beta alpha minus I beta minus gamma k square. Hold a second, I have done I beta k minus gamma k square. So option 3 is the correct answer. Option 3 is the correct answer. Now another question is from 2015 December only. Question 47. Function fx satisfies the differential equation d2f by dx square minus omega square f equals to minus delta x minus a, where omega is positive. The Fourier transform f tilde k equals to minus infinity to infinity dx e to the power ikx fx of f, and the solution of the equation are respectively. Now fx satisfies the differential equation, this one. Okay, now the Fourier transform of f tilde k is defined to be like this. Okay, now for x not equals to a, as we already know, for x not equals to a, delta x minus a will be 0. Delta function doesn't exist. Then the differential equation becomes d2f by dx square minus omega square f equals to minus delta x minus a. Sorry, this won't be there. This will become 0. Okay, so this will be 0. Now now if we solve this differential equation, it is very known to us. How it is solved, you already know. D square minus omega square f equals to 0, and take the auxiliary equation to be m square minus omega square. I am not doing the whole process again. M equals to plus minus omega, plus minus omega. So this will become the function. Then the solution will be of the form a e omega x plus b e minus omega x. Okay, now for the region 1, that is for minus infinity less than x less than a, f1x, only the first term will survive here, a e to the power omega x. Why so? When if we put minus infinity, this will exist, this function will exist. If we this first term only will exist, second term will make the function to be indefinite, the solution to be indefinite. Now we take the another limit a less than x less than infinity. This becomes f2x equals to b e to the power minus omega x. Okay, now the above form of solution is taken because for the existence of Fourier transform, as x tending to as I've already told you, when x tends to plus minus infinity, fx must tend to 0 for the solution to exist. Okay, now fx should be continuous at now we already know by this fx must be continuous. Fx must be continuous at x equals to a, continuous at x equals to a, that is f1 x equals to a equals to f2 x equals to a. So now what we do is this becomes ae omega a equals to be minus omega a, this one, putting these putting this condition over this one. Okay, over this one. Now over this one, a e to the power omega. Now if we take taking a e sorry a to be e minus omega a and b to be e to the power omega a, the above equation satisfies, right? So now we have f1x of the form of f1x equals to e to the power omega x minus a, f2x equals to e to the power minus omega x minus a. Okay, now if we take the general form of this, we get omega modulus of x minus a. So when x is negative, this will become omega x minus a. When x is positive, this will become this. I mean to say, if x is negative, then this becomes this. If x is positive, then the solution becomes this one, right? Now what we do further is so the solution. Now if you see the if you see this solution, and that is modulus of x minus a minus omega x minus a, only two solutions are only one of it is possible, this one. These only have this term, right? So but it should be when it is being taking modulus, when we are taking already modulus, then it will distribute into these two functions. We need only two functions, but in the first option we will get four such functions. We don't want those four such functions, we only want two. So option 2 will be the correct, this part will be the correct one. So the solution is 1 over 2 omega. I'm not deriving the coefficient right now, since it is already obvious by seeing this options. Why to waste time in deriving the coefficients? It is not necessary. So I'm taking, so the solution of the differential equation will be fx equals to 1 over 2 omega e to the power minus omega x minus a. Now Fourier transform of fx is, that is f tilde k, that will become minus infinity to infinity fx e to the power I kx dx. This becomes minus infinity to a 1 over 2 omega e to the power omega x minus a e to the power I kx dx plus a to infinity 1 over 2 omega e to the power minus omega x minus a e to the power I kx dx. Now we will solve this equation. What we get is 1 over 2 omega e to the power minus omega is the constant, it is taken out, minus infinity to a e to the power omega plus I k x dx plus e to the power omega a is again taken out, since it is a constant term, a to infinity e to the power minus omega minus I k x dx. Okay, now 1 over 2 omega e to the power minus omega a e to the power omega plus ik x omega plus ik, limits are minus infinity to a, plus e to the power omega a, e to the power minus omega minus ik x. This becomes minus omega minus ik a to infinity. Okay, now e to the power ik by 2 omega 1 plus omega plus ik plus 1 over omega minus ik. This becomes e to the power ika omega square plus k square. So what we see is option 2 is obviously correct. We already knew it from the solution only. So from the solution of the differential equation only. So option 2 is the correct answer. Option 2 is the correct answer. Option 2 is the correct answer. Okay. Now the last question of the video, that is and the topic also, that is from 2015 June. The Laplace transform of 6t cube plus 3 sine 4t. First I would like to tell the Laplace transform of the any function which is t to the power n factorial, any function of the form like this, s to the power n plus 1, and a Laplace transform of sine at equals to a over s square plus a square. Now the question, now the solution goes like this: L over ft. ft is our given function. I am taking this to be ft. That is 6t cube L over Laplace transform of 6t cube plus 3 sine 4t by using the linearity property. That is L 6t cube plus L of 3 sine 4t. This becomes 6 of Laplace transform tq plus 3L of sine 4t. Now by using these formulas of Laplace transform, we get 6 multiplied by 3 factorial over s to the power 4 plus 3 multiplied by 4 over s square plus 16. This becomes 36 over s to the power 4 plus 12 s square plus 16. So option 1 is the correct answer. Option 1 is the correct answer. Hence this topic is covered and it is also finished. So see you again in the next video. Thank you for watching. Take care and stay safe.